Okay. Starter will be fine. No, sorry, I'm in the wrong thing. This one. Any idea how you could simplify this fraction?
Put the denominator into brackets.
Yeah, and what would that be?
3 and 1, n plus 1, n plus 3.
And how could you simplify that fraction, or what would it be after you simplify it?
Just cancel out the n plus 3s.
And what would you get?
N plus 1.
And on the top?
1.
Yeah, fine. I'm glad we didn't do that the long way.
What's the long one?
Oh, there's subbing in different things and going from there. How would you simplify this one?
N plus 3, n plus 2 over n plus 5 over n plus 5, n plus 2.
And after you simplify that, what do you get?
N plus 3 over n plus 5.
That's it. Okay, fine. Easy peasy. How about this one?
The 5 goes outside the bracket, then x plus 2 over, take a factor of x out, so you get x plus 2, and then cancel those 2 out, so you get 5 over x.
5 over x. Prove that when x is a multiple of 5, this can be written as a unit fraction. So another way to write this would be as 5 times 1 over x. Do you know it? Okay, yeah, so a unit fraction is when the numerator is 1.
Okay.
That's what that's about. Okay. How would you do this one? No, too easy.
Yeah.
Fine. Okay, let's try this. Multiplying.
So n plus 5, n minus 3. And then the bottom is, let's just keep it with 2n plus 1 for now. And then when you times it, you get n plus 5, n minus 3 over 2n squared.
What would you get if you didn't expand the bottom brackets?
Just 2n plus 1.
Times by n plus 5?
Yeah.
Can you simplify that?
Without expanding it?
Yeah.
Just take an n out?
No. Anything? Any common factor?
Just take n plus 5.
Yeah. And what do you get?
N minus 3 over 2n plus 1.
That's it. And if we go back to this line up here, you see how we had n plus 5 here and then n plus 5 here?
Yeah.
And so if you wanted to, at this point, you can cancel it, because when you multiply fractions, they're just going to go across. But so the whole point of the way you simplify is you don't expand the brackets, you factorize into brackets and cancel down anything they have in common. Am I missing something from this? Who knows? Okay, that one's done. Next one. B. Fine. Fine. So an expression that consists of one polynomial divided by another is called a rational expression or algebraic fraction. Okay, so a fraction with algebra in it, with letters, is called an algebraic fraction. That's the one we just did, I believe. What do you get here? How do you divide fractions?
6/20.
Yeah. So keep, flip, change. How about this one?
Is that an 8?
Yeah. Is it cut off?
Do I do this without... Shall I like make them brackets and stuff?
Yeah.
Like even the 4n plus 4 one?
Yeah, anything you can.
Okay, so 4 on the outside, then n plus 1 over n squared minus 9.
Can you factorize that?
I feel like I can't. I could take an n out, but then that means that, but I can't take an n out.
So something squared take away something else squared?
Oh, so like n and then... Or do you take the n squared out and then just put through?
Another way to write it would be n squared minus 3 squared. Does that look familiar?
Yeah. Would that do?
Sorry?
Would that help me if I just factorize that?
Difference of 2 squares.
Oh yeah, true. So n plus 3, n minus 3.
Yeah. N minus 3. Okay.
And then I'm actually going to use my calculator because I can't bother. So 2n minus 1 n plus 3 over 8.
Yeah.
And then you times them, so you get 4n plus 1, 2n minus 1, n plus 3 over 8, n plus 3, n minus 3. Cancel out the n plus 3's. So you get 4n plus 1, 2n minus 1 over 8 n minus 3. Do I do anything else?
There is something else you can do.
And then do 1 over 2.
Yeah, correct.
So you get n plus 1, 2n minus 1 over 2 n minus 3.
Well done. Any questions there?
No.
Over 2 n plus, sorry, n minus 3. And you don't have to factorize at the, excuse me, you don't have to expand the brackets at the end either, because maybe you'll use this for a part B or part C of a question and you'll want it in its simpler form.
Okay.
Okay, fine. Yep, keep, change, flip, fully factorize, cancel down. This is an exam question. I think you'd be fine with A, am I right?
Yeah.
And then this one we just haven't done yet. We'll do it now. Let's see. Thumbs up, I believe. This one, similar. Okay, subtract these two. Without your calculator.
I won't.
How do you subtract fractions?
You flip it, then add them, but then use the same denominator. So over 12.
Okay.
And then do 3 times whatever it. So 3 times 3 is 9 over 12 plus 8 over 12.
And it's not keep, change, flip is for dividing. This just stays as subtracting.
Oh, is it? Oh, yeah. Equals 1 over 12.
Yeah. And so the way you did this, you had 3 over 4, take away 2 over 3. The second denominator is 3, so you times the first one by 3 over 3. The first denominator is 4, and so you multiply the second one by 4 over 4. What is 3 divided by 3 or 4 divided by 4?
1.
Yeah, so you don't change the value of the fractions, you're just changing the format to get a common denominator. You multiply by the other denominator, and so you have to multiply by the top so that you're just multiplying by 1. Let's keep it the same so you're not changing anything. Okay, write this as a single fraction.
Do you expand the 5x in x minus 2?
No, don't have to.
Okay, so is it just 2x plus 6?
Minus 6, I believe. Minus between them.
Yeah, but doesn't it cancel out?
Oh, you might be correct. I'm just doing it in my head. Okay, go on. 2x plus 6 over.
Then just the two denominators. I just put 5x squared minus 10, but it could just be that. Yeah. 10x, sorry.
That's fine. Can you factorize the top?
Yeah. Take out a factor of 2, so then you get x plus 3.
Yeah. We can't make that any simpler. The reason why I said can we factorize the top is because if we could have factorized out, say, if the bracket had been x minus 2, then we could have made it simpler. And so it's just good practice to fully factorize to see if you can fully simplify. Yes, it was a plus, minus. Fine. Express this as a single fraction in its simplest form. How do we do this?
3 over 2x plus 1. 4 is just 4 over 1.
Yeah.
And then do the same thing.
Yeah.
Then you get 8x plus 7 over 2x plus 1.
That's it, and nothing factorizes there. These are getting more tricky, but it seems like it's the same with nothing to it. I think you'll be fine for that. They get very, very tricky. I reckon you'd be... What do you think? Oh, we better try this one, sorry. Yeah.
X over x plus 2 minus 6 over... Do you have any partial fraction questions?
Yes, so this is kind of combining fractions forward, and then after this is partial fractions where you're separating them back out again.
Yeah, okay, how do you minus again? How do you minus again? Oh, same thing, isn't it?
Same as add, yeah.
Oh my god, it's going to be a lot in one denominator.
What do you notice about the two denominators?
They both got x plus 2 in it.
And so that means that your common denominator only needs to be x plus 2, x plus 3, and x minus 1. You don't have to put x plus 2 for both of the things on top because it's already a common factor.
Okay, so x plus 2, x plus 3, x minus 1, minus 6, x plus 2.
Yeah, and then from then on you would just clean it up. So the only reason why I wanted to do that was because you already have because x plus 2 is already common, you don't have to multiply them both. What would have happened is if you fully expanded and fully factorized, you would have x plus 2 on the top, x plus 2 on the bottom, and at the very end you would just cancel them down anyway. So there you just prevented having to do that. This one, okay, so when you fully factorize, you've got, yeah, the x plus 2, yeah, that's it. Okay, grand, okay. Next thing. So this is an exam question. How could you factorize the denominator?
Which denominator? That one.
Yeah.
Take out... Well, you've already done it. Three x plus 2, 3x minus 2.
Well done. And then you would go from sorry, what would the next thing be that you would do?
Then put them over the same denominator.
Even before then?
Cancel out the 3x plus 2's.
Yeah, and then from then on it's simple. So this question could be challenging if you had multiplied this by 3x plus 1 and you had multiplied the 2 by 9x squared minus 4. You could bring them together, you could fully expand, fully factorize, and then at the end cancel out the 3x plus 2 over 3x plus 2. It's easier if you fully factorize everything at the beginning and then simplify. Right away you get rid of some of the factors. Okay, write this as a mixed number.
3, 1 over 6.
3 and a sixth, and that comes from it being 6 divided into 19 goes 3 times remainder 1, or another way to think of it is 19 is 18 plus 1. 18 over 6 plus 1 over 6 is 3 plus 1/6, which is the same as 3 and a sixth. So this fraction, this is an improper algebraic fraction because the power of x is bigger than the power of x on the top than on the bottom. So this 19 over 6 is an improper fraction because the number on top is bigger. X squared plus 2 over x is an improper fraction because x squared is a higher power of x than the bottom, x to the 1. Can you convert this from an improper fraction into a mixed number, if you like we did with the 19 over 6?
Okay. So 2 x's go into that.
Remember 19 over... Okay, remember the 19 over 6?
Yeah.
And that's the same as 18 plus 1 over 6.
Yeah.
The way you add fractions, if you had 18 over 6 plus 1 over 6, you just add the two top numbers and put them over the denominator. You can also do that in reverse. So what would you get if you did that in reverse for this one?
X squared over x
Mm-hmm.
plus 2 over x.
And can you simplify anything there?
X squared over x is just x.
Yeah. And so what's the final answer?
X plus 2 over x.
Yeah. And so the final answer down here for this one would be 3 plus 1/6, which we write as 3 and a sixth. If we were to do the same thing with this algebra, we would do a big X and then a little 2 over X. But we it's the exact same idea. We're just using letters instead of numbers. With letters, we just leave the plus. Let's see. Fine. Sorry, did I skip anything? No. Okay, try this one.
X squared over x plus... Oh, wait, no, hang on. X squared over 2x... No. X squared over x plus 3 plus 2 over x plus 3. Can I factorise the x squared?
Yeah, you could try factorising it.
Okay, so factorise it, it's x plus 3 x minus 1.
Oh, okay. And so what is that?
And then the x3 cancel out. So then you just get x minus 1.
Yeah, okay. We got lucky there. X minus 1. Yep. Okay, how about this one?
What do you want to do with it?
Change it from an improper fraction into a mixed algebraic number.
Okay, so x over x plus 2 plus 6 over x plus 2. And then x divided by x plus... Oh, no, that's that.
There is another way to do this. What if I wrote... You know how we had the 19 over 6? And we wrote that as 18 plus 1 over 6.
Yeah.
Because we can divide those two.
Is that with 3? Like the 6 and the 2?
Well, what would have to be on the top for you to divide it by the bottom? In this case.
I don't know.
Or if the top was to factorize, what would need to be on the top to simplify it with the bottom?
X plus 2.
And so the top, what if I wrote it as x plus 2? What else would I have to write to make it equal to what it actually is?
I don't know.
Plus 4.
Oh, yeah.
Yeah. Okay. Now, how could you separate this out so that you can simplify something?
What, that did that whole... cancel out the 2's.
No.
You not do that?
No. So we usually split along where the plus is. The problem
So
is...
did x over x plus... Oh, x over x plus 2.
we tried that before, and that wouldn't divide. It would only divide if we had x plus 2 on top and bottom.
Yeah, true.
So you could split it here.
So you get 4.
Well, you get x plus 2 over x plus 2.
Which is 1.
Yeah. What else do you get?
4.
And if you're adding a fraction, this one we get 18 over 6 plus 1 over 6.
4 over x plus 2.
Yeah. And so final answer?
4 over x plus 2.
And
1.
yes.
Oh, that was too complicated.
And so the idea there is to get the same thing on the top and bottom so you can cancel something down. Maybe I'll just give you a different method that doesn't require any kind of thinking. Okay, yes, here we go. The different method is long algebraic division. Have you done that before?
Yeah.
Okay, maybe we'll stick to that. So this one, using long algebraic division or any other method you like, how would you do this one? And the way you divide it in is you say how many x's in this on the outside are in the x's on the inside.
3.
Yeah. And so what is x plus 2 times 3?
3x plus 6.
Yeah. What do you get?
4.
And any idea how you can write your answer?
3 plus 4 over x 2, so...
Yep, that's it. That's all I have to do. 3 over 4 plus 3 plus 4 over x plus 2. And if I just if I go back to this one, x plus 2 and x plus 6, that goes in once with a remainder of 4, 1 plus 4 over x plus 2, and we got that same thing. And so this is kind of where the long division comes from. The other way of doing this one, on the top, this 3x plus 10, you could have x plus 2, x plus 2. So that's 1, 2, 3 x's. And we have how much? 2, 4, 6. So we have 4 left over with x plus 2. And so that's 1 plus 1 plus 1 plus 4 over x plus 2. Or 3 plus 4 over x plus 2. And so same thing.
Yeah.
And so maybe the algebraic division method will work better for you because it doesn't require any kind of thinking or understanding or anything. Let's see. So to convert an algebraic improper fraction into a mixed number, divide the denominator into the numerator, and then you write your answer in this form. So the quotient is like your answer, and then plus the remainder over the denominator. So the remainder on top. X plus 2. Let me think about this. Okay, let's try this.
Do I factorize the top first?
I don't think it does factorize. I'll just go straight to the long division. Over means divided by. Same thing.
So is it how many x plus 2's go into that?
Just compare the x's. How many x's go into x squared, or x squared divided by x gives you what?
2x's go into x squared.
No. You're thinking of x and 2x. This is x and x squared.
So 1.
Simplify. X squared over x.
Is x?
Yep. And so you can have x in your answer.
Oh, okay. And then x and 6x is 6.
Slow down. You then multiply this part of the quotient by this.
So 2x.
So first, so that's going to be 2x in the first bit.
Wait, what?
So it's this times both of these.
Oh, it's algebraic division. Okay, x squared plus 2x.
Yeah. The first always has to be the same.
Yeah. So the next one is 6.
So what's right?
There's 6x's that go into 6. Oh, you want me to do that first? So it's 4x.
So 4x. Next you'd bring down your minus 3. And do it all over again.
Yeah, so 4.
Yeah.
Then 4x plus 8. So they minus, then minus 3 minus 8 is minus 11.
And so what will be your answer?
Some x plus 4 plus
Sorry.
minus 11 over x plus 2.
Well done. Any questions there?
No.
Okay. X plus 4 minus 11 over x plus 2. And I did it a slightly different way. Both are fine. Let's see. Step 1. Divide the biggest x term in the numerator into the biggest x term denominator. Write the answer on top. Multiply the quotient to the answer on top by the numerator. Put it underneath. Subtract. Bring down the next unused term and then repeat. Okay. I think we're good. Let's see. This one, I believe you'll be fine. This one, is it any more difficult? I don't think it is. I can convert linear rational expressions into mixed numbers, x a half or tick.
Tick.
And I can convert quadratic rational expressions into mixed numbers.
Tick.
Okay, so that was the one just. Okay, here we have a cubic. Let's try cubic.
Okay, so okay, so 2x cubed divided by x equals 2x squared.
Okay. So, is what, sorry?
2x squared.
2 divided by 2?
1.
So I believe it would be 1x squared.
Wait,
Two-
why is that 1?
2x cubed over 2x?
Why is it over 2x? Oh, it's 2x. Yeah. True.
Okay. Go
So
on.
x squared. And then x squared times 2x minus 1 equals 2x cubed minus x squared.
Mm-hmm.
So then you get 6x squared minus x plus 4.
And I would just deal with 6x squared minus x.
Why?
You won't be able to do all three in one go. So just bring down the next term, the next unused term.
Then 6x squared divided by 2x is 3x. Then 3x, 2x minus 1 equals 6x squared minus 3x. Which is 4x. Then 4x divided by 2x equals 2. Equals 2. Then you get 2x minus 2.
Not 2x. It always has to be the same.
2 and then 2x minus 1. 4x minus 2.
Yeah.
4x minus 2 gives you 6.
Minus 4 minus minus 2?
Minus 2.
Yeah. And so final answer.
X squared plus 3x plus 2 minus, or is it plus?
Minus?
Minus 2 over 2x minus 1.
Minus 1. Got it. Got it. So that was a cubic divided by a linear. Did I do something wrong here? Let me just check. Do I have the definitive answer? Who knows? This one, hang on. Maybe I made a mistake in looking out. Oh, no, it's fine.
That's a different question.
Yeah, I think it's a different question. X minus 5. So this one, how would you do this one?
X cubed plus x squared plus 2x minus 1 over x squared minus 1. So x cubed divided by x squared is just x.
Mm-hmm.
And then x squared minus 1 is x cubed minus x. So x cubed plus x
So
is x cubed.
So the problem here is that one is x squared and the other is x.
Yeah.
If you have a question like this, and the reason why I left that space, the easiest way to do it is to rewrite this as x squared plus 0x minus 1 if there's a term missing.
And then what do you do?
So now same thing again. So that's x cubed. What would you get for the middle bit?
Oh, okay. So x cubed. 0x times x is... What's that?
X times x.
X squared.
And so we can write it as 0x squared. It's just to fill in the blank space. And go on.
And then wasn't it minus x?
And then minus x. So what do you get there?
Was it minus x?
Yeah. 1 times x times minus 1.
Okay. Oh yeah. And then that cancels out. Then x squared minus plus 0x is just x squared. Then 2x minus x 3x.
Yeah. And then from there you just continue as normal.
Yeah.
So it helps to put in a plus 0x if you see that one term is missing. Sometimes they'll have 2 terms missing, like x cubed minus 1. And you'll have to put in plus 0x squared plus 0x. And it's just so the x squareds line up with the x squareds, the x's line up with the x. There's a much fancier way to do it, but if you just put in a 0x, then you can use the exact same method that you were using before. So what would you, let's take this bottom one, what would you divide into the top one? If you're doing long algebraic division.
Do we just do what we did before?
So what would be on the outside?
So x cubed divided by x squared equals x. Is it?
Yeah.
And then do
Hello? Saba? Sorry, I just went for a second. Yeah, go on.
You change that to x squared plus 0x plus 1.
That's it. That's the only part I wanted to check. That's fine. And then you just follow the same system. Fine. I'm happy. This is what an exam question looks like for these. Is it worth doing, or you think you'd be okay with it?
Yeah, I might as well do it.
Okay. So
Yeah.
this is x to the 4.
To do 0.
Yeah, should make it easier.
Okay, so 3x to the power of 4 divided by x squared gives you 3x squared.
Yep.
And then 3x squared times minus 0x minus times x squared minus 0x minus 4 gives you 3x to the power of 4 minus 0x minus 12x squared.
So I believe it would be plus 0x cubed, and then
Oh yeah.
minus 12x squared. Yeah. Okay, go on.
And then that cancels out, and then minus 2 minus plus 0 is just minus 2x cubed.
There we go. So minus 2x cubed, and the other one?
And minus 5 minus 12 will give you 7x squared.
Okay, what's next?
And then you do minus 2x cubed divided by x squared, which gives you minus 2x. And minus 2x gives you minus 2x cubed plus 0x plus... Oh wait, 7x, isn't it? Wait, what? Yeah, it doesn't matter. Plus 0x. And then plus 8x cubed.
Minus 4 times minus 2x?
Oh, sorry, I was reading the wrong thing. Minus 4 times minus 2x is 8x.
I just noticed we have no x term on the top. We have to the 4, to the 3, to the 2, and no, just x by itself.
Then you do 0x.
Yeah, so we just add in a plus 0x, which we could have done to the original one. I just didn't notice it.
Maybe.
Okay.
Yeah, and then minus 2x cubed plus 0. Then minus 2 plus that cancels out as 7x squared plus 8x.
0x minus 8 minus plus 8x?
Is that just minus 8x?
Yeah.
And then 7x squared divided by x squared equals 7.
Yeah.
Then you get 7x squared minus 7x minus 28.
Okay. And what do we do there?
Then those cancel out. Minus 8 minus 0 is just minus 8, isn't it?
Mm-hmm.
Then minus 28.
We have this blank space. Why is that?
Don't know.
We never brought down the minus 4.
Oh yeah.
Okay.
And then minus 8. No, you can't do that, can you? What's minus x divided by x squared?
Sorry?
Oh, sorry. You do still do the minus.
Yeah.
Minus 4 plus 28 is 24.
Yeah. And so, yeah, so we now have reached the end of it. And so what is our answer?
3x squared minus 2x plus 7 plus minus 8x plus 24.
And in terms of A, B, C, D, and E?
A equals 3, B equals minus 2, C equals, I don't know, you've covered it.
Oh, sorry.
You still covered it. 7.
C equals 7.
D equals minus 8, and E equals 24.
E equals 24. Three minus 2, 7. I should have written minus 8 and 24. Yeah, got it. Any questions there?
Nope.
Okay, so that's the exam question for that one. These are some other exam questions. Let me see, that's the one we did. And then this one on the bottom is adding and subtracting. I'm confident with that.
Yep.
Let's see. Yeah. Okay, so partial fractions. So all of what we were doing is taking like two or more fractions and bringing them together. And partial fractions is the reverse of that. They give you one fraction, and you have to figure out what two fractions were added or subtracted to make that fraction.
Yeah.
Let me just see. So partial fractions is the reverse of rational expressions, those algebraic fractions. Yes, I just said it. Okay, so here we've got these two. No. Hang on. Nah, I'm skipping this. Yes, let's do this one. So we're given one fraction, we have to split it in two. How does this work?
So 4 equates to
no. Sorry, we better do the one before it. Okay, go on. We'll try, but you might not know how to do it.
Just did rub it out. Wait, hang on.
Sorry.
4 over x plus 1, x plus 3. A over x plus 1, b over x plus 3, and then you do 4 for the 3 lines. A times x plus 3 plus b times x plus 1, and then if x equals minus 3, b equals minus 2b.
So 4 would be equal to something.
Minus 2b.
Yeah.
Then b equals minus 2.
Yeah.
And then if x equals minus 1, 4 is equal to minus 1 plus 3 is 2a. Yeah. So then a equals 2.
And so what is this one fraction written as two separate fractions?
2 over x plus 1 minus 2 over x plus 3.
That's it. Okay, so you're already good for this. 2 minus 2. Fine. This one, I reckon you'll be fine. This one, let's try this one, because it has an x on top.
Is a 2x plus 5 plus b x minus 1. So if x equals minus 2,
let's start with
let's do b.
Let's do 1, yeah.
Yeah, so b is 1, so then you get 7, 2 plus 5, 7a, so a equals 1.
Yeah, you're going to be fine for the rest of the question.
Okay.
Yeah, a equals 1. Skip. Let's see. Yes, this is the one I wanted to do. How do we do this?
Okay. Can you move the question like down like a little bit?
Sorry, I can't see it from your perspective.
Yeah. No, that's fine. That's fine. That's fine. You don't need to bring it that down, but yeah.
Alright.
Okay, so 9x minus 14. 3 lines. A is got to have x minus 1 squared. X plus 4. X minus 1 squared. It's already got an x plus 4, so do you just put the x minus 1 squared?
Mm-hmm.
Okay. Plus b x plus 4 x minus 1
Mm-hmm.
plus c x plus 4, and then if we do x equals minus 4, so 9 minus 4 is, do you know when you substitute x for minus 4, is it 9 minus 4 or is it 9 times minus 4?
Always times.
Okay, so 9 times minus 4 is minus 36.
Mm-hmm.
Minus 36 minus 14 is minus 50.
Mm-hmm.
Equates to minus 4 minus 1 is minus 5. Minus 5 squared is 25. 25a plus minus 4 plus 0. So 0 times b goes, and so does c.
Mm-hmm.
So a equals minus 25.
25a is short for 25
So
times a.
minus 2.
Yeah.
And then if x equals 1, so then we get 9 minus 14, which is 5.
14 minus 9 is 5. 9 minus 14?
9 minus 14 minus 5.
Yeah.
So then there's nothing for a, plus there's nothing for b, and then c is 5c. So c equals minus 1. And then when you know everything else, so minus 14 minus 2 a is 2 minus 2. So do you make x equals 0?
I don't think that would work.
And then substitute all the other ones that we found out.
Okay, so you could sub in the other things we found out, yeah.
0 minus 1 squared is b, 0 plus b plus, what was c, minus 1. So 14 plus 3, 7, is b 17?
And b equals 17, I'm not sure. Let's take a look.
I think it's a bit low.
Nope, b was 2. So a was minus 2, c is minus 1.
Yeah, I was going to say it's a bit large, hang on.
9x minus 14. So if we subbed it in there. So
Always do this, wait, hang on. Plus b minus 1. So if we're making x equals 0, so minus 14, and then 0 minus 1 is minus 1 squared. We already know what a is.
yeah. But, so sub it in.
So minus 2.
Mm-hmm.
Then 0 minus 1 is minus 1. Minus 1 squared is just 1. So a. And then plus 0 plus 4 is 4. 4 times 0 minus 1. So 4 times minus 1 is minus 4b. And then 0 plus 4 is 4c. But c is minus 1. So 4 times c is minus 4.
Mm-hmm.
And then 4 and 2, so you get plus 2 is minus 12, plus 4 is minus 8, equals minus 4b, and then b equals 2.
Yeah, that's it. B equals minus 2. Any questions there?
No.
Okay, so that was the one that I wanted to look at, but you're already good for that. So you're good for partial fractions, definitely in the beginning. Yeah, how did you find that, Saba?
That's good.
Anything in particular you want to do next time? If you want, we can just continue into partial fractions. What is it? So you really have to do. I expected you would be that you'd find the start of the rational expression stuff easy, but you have to do it before you do partial fractions. So partial fractions, repeated factors, algebraic division. So we've actually already done some of that stuff. Algebraic division. I've done most of it. If you like, we can. I'll check if